This is part 5 of your topic 2 kinematic 2D motion notes. In this section we're going to talk about relative motion, and with relative motion we're looking at velocity measurements that are going to differ in different frames of reference. So for instance, two observers at different positions while observing the same object may not agree upon the movement of the object. Well, this is pretty important, guys, and this is why it's called relative or in perspective to kind of motion, because what's missing? Like, what do you have to have in order to say, according to my blank, 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 then I can say that this object was moving at a constant velocity, or this object was at rest, or this object was moving towards the horizon or away from the horizon, etc., etc. So what are they missing here? What's this why? Why can two observers observing the same object not agree upon the motion of it? Because a frame of reference is missing. So pretty much it's up to whomever's frame of reference they're using. Well, while I was flying the plane, I thought this. Well, I was standing on the ground watching you fly that plane, and I thought that. Okay, so depending upon whoever's frame of reference you are referring to, you may see the same object moving, but with different movement. Once again, based on your frame of reference. So you have to have a frame of reference. So for instance, let's stick with this scenario. So this pilot is flying a plane, and this is like a bird's eye view, so you're looking down onto this plane as it is flying, okay? And this pilot drops a package, and this package looks like it's always staying right here into relationship to where the pilot is, right? So it's always just going to be in this position throughout its time. So when you are in the plane watching the package fall, you are thinking that that package is moving straight down, right? But what if you're standing on the ground watching this happen? So yeah, it's still staying at that same placement from where the pilot was, like exactly what the pilot was seeing up here, that distance between them. That's very, very true. But what is changing here? All right, you can see that if we connect our dots, that this object is utilizing 2D motion, right? It's moving both forward and it is moving downward. So then we could figure out what theta is and figure out what our resultant is based on knowing our x component and our y component. So that's where the 2D motion would come into play, because you are at rest. You have a frame of motion. Whereas, okay, we're both moving. I'm not exactly sure what the motion was. It looks like it was just 1D motion. So from the pilot's perspective, he's looking at 1D motion. But from your perspective on the ground, you're showing 2D motion. Agreed? Okay, let's try one more example. So while walking in a straight line, disregarding air resistance, you drop your pencil. What's going to happen? So like literally, leave the computer for a second, all right? A little bit of an open area. Do it. Get up. Do it. All right, so you're up. You got your pencil, your pen, whatever in your hand. Take like 4 steps forward and drop your pencil. Continue walking forward. Stop. Where'd the pencil land in relationship to your feet? Is it behind you, beside you, or in front of you? Well, for majority of us, try it again. Pick up your pencil. Come back here. So I want you to take 6 steps forward, and on the 4th step, drop your pencil and stop once you finish your 6 steps. So 1, 2, 3, drop, 5, 6. Look at your pencil. Where is it? Should be like right beside you, right? Because the pencil had that same momentum built up of, I want to stay continuing moving forward. I want to stay continuing moving forward. So it's moving forward, but the force of gravity, not acceleration due to gravity, but the force of gravity is pushing that pen back down, or pencil, whatever you're using right now. So it's moving in 2D motion. Make sense? So yeah, there's your visual on that. So once again, these questions here just say, discuss the path your pencil would take while you were still walking. Where would the pencil land in relationship to your body? Right next to you. What path would the pencil seem to take? A parabolic path. And then who would witness the pencil making a parabolic path? A person that was standing still, right? A person that was standing still would see this 2D motion. Because to you, it's like, oh my gosh, it landed right beside me. It must have just fallen straight down. Well, that's because you were moving along with the pencil. just like the package was moving along with the plane. So from the pilot's perspective, it looked like it was just falling straight down. 2D motion, need that frame of reference. Okay, so there's some other ones. Unfortunately, I can't click on these right now, but here's your link. Please do go to physicsclassroom.com, and in physicsclassroom.com, you will see that this boat is going to be moving across the river towards the other side of the bank, but the current is going to be pushing it up. So the boat is really going to be taking this type of a path, which leads you to this triangle right here is what you guys should be seeing in this video. So please do take a second, not right now, but when you're done with this slide or this video on relative motion, please do go to physicsclassroom.com and copy and paste this link into there. All right, next thing that we have is plane in the air problems. This is important for you guys to know. Okay, so one of the things that I want you to understand is the use of terminology. So the first thing is if you have a headwind, that means that as you're flying, wind is coming at you in the opposite direction. So it's like slowing you down. Tailwind is as you're flying, wind is coming in the same direction, so it's pushing you forward, therefore you're flying even faster. Whereas a crosswind is you're flying towards the north and the wind's coming towards the west or coming towards the east. All right, or vice versa. You're flying towards the east or west and the wind's coming from the north or the south. So that would be a crosswind that you would be experiencing there. So technically, these two are showing you 1D motion and this one is showing you 2D motion, right? Because you would be able to draw a triangle from the 2D motion one, where the 1D motion ones, it's just a positive value of this and a negative value of that based off of the direction. It's like a positive 6 and a negative 3. So the plane's really only moving 3 meters per second, for instance. Okay, so please understand headwind, tailwind, crosswind. Check this problem out here. It says a plane can travel with the speed of 80 miles per hour with respect to the air. Determine the resultant velocity of the plane, magnitude only, if it encounters a 10 mile per hour headwind. Okay, so headwind means that it's going opposite your direction. So you have a positive 80 and a negative 10, so that should give you a positive 70 miles per hour. So that's for A's answer. And then for B, it says with a tailwind. So positive 10, positive 80 equals positive 90 miles per hour. So that would be B's answer. So those are just 1D motion, right? You just added them together. Whereas if it would have said a crosswind of, you would have said, okay, so I'm flying this way, the crosswind is heading this way, so where's my plane really going to be landing? So you have to use Pythagorean theorem to figure out the magnitude, and then inverse tan of either your bow tie, y over x, or your hourglass, x over y, triangle to figure out in what direction. All right, so the next thing that we have here is our sample problem based off of relative velocity. Our sample problem on relative velocity says that a boat is heading north across a wide river with a velocity of 10.00 kilometers per hour relative to the water. The river has a uniform velocity of 5.00 kilometers per hour due to the east. Determine the boat's velocity with respect to the observer on the shore. So there is a frame of reference. The observer on the shore is standing still. He's at rest, we would say in physics. So what we know here going into the problem is that the velocity of the boat is heading in the y direction. So we're going to say 10.00 kilometers per hour. And the river is flowing due east, and that would be a positive 5.00 kilometers per hour. And you know that the theta for y, since you are heading like north, that would be 90 degrees, and you know that your theta of x due east is 0 degrees. Make sense? So, oh wow, yeah, I didn't even think about putting those givens down. Well, not always are they going to tell you the number, like a quantity inside the problem that you need to state as a given. Make sure that you remember to just put it down in there, because especially when you have 2D motion, you should have a magnitude and a direction, right? Because 2D motion is vector, magnitude plus direction, quantities. Okay, so moving on with that then, so you want to know, so what's my resultant velocity and my resultant theta? Obviously that resultant theta will be in degrees, and your resultant velocity will be in kilometers per hour. So, looking at your triangle over there, they already did the I part of I guess for you. You would obviously need to write that down again, but we'll keep that there to refer to. This VWE, that's VX. This VWY, or VPW, is VY. Here's your theta, it's between your first vector drawn and your resultant, and then here's your VR, and there's theta R, that we were trying to solve for. Okay, so now we kind of sort of dressed up the picture so it looks like the one that we actually want to assess. So to figure out a magnitude, we want to do Pythagorean theorem. So that's just simply going to be the square root of Vx squared plus Vy squared equals Vr. Get your calculators out, please. Okay, so that should be 5.00 squared plus 10.00 squared equals. Plug that in your calculator. 5 squared plus 10 squared equals square root, second answer, equals. In your calculator, you should see 11. Are you? Hopefully, 11.18. Okay, so then looking over at your givens, you only want 2 sig figs. We're not looking at degrees for givens, okay? You look at your magnitudes for your givens there. So you only want 2 sig figs. So, I'm sorry, 3 sig figs. So your final answer is going to be 11.2 kilometers per hour is your resultant velocity. So that's how the observer on the shore really thinks the boat is traveling at a rate of 11.2 kilometers per hour. Okay, so now theta is inverse tan of opposite over adjacent. Opposite is Vx. Can you see that? Vx is opposite. Vy is adjacent. Okay, so that would be the inverse tan of 5.00 divided by 10.00. Both of which are positive, right? Because you're heading north and east, so they're both positive. So inverse tan of 5 divided by 10 is, put it in your calculators, inverse tan of 5 divided by 10. 26.56 is what your calculator answer is. So therefore, theta is going to become 26.6 degrees. You can say with respect to the river, but whatever. I already know that it's positive, so don't worry about putting terms with it as well. With respect to, with respect to, with respect to. I don't mind that. All right, so after that, we are now going to move into our projectiles that are launched, and then projectiles that are launched at an angle, which will be the 6th video in this part. You are done with this part on relative velocity. Now you can do your relative velocity worksheets.